Ladies and gentlemen, good afternoon. Welcome to HSNU, the affiliated senior high school of National Taiwan Normal University. My name is Vincent.
And my name is Arlene.
We are from the science class, and we are proud to be your hosts for this afternoon.
We are very honored and excited to host the only high school event of this year's Tang Prize on our campus. And on behalf of HSNU, we would like to warmly welcome everyone who's here today.
Sitting in the audience here with us are some distinguished scholars and honorable guests. Please let me take a few moments to introduce them to you. First, the 2018 Tang Prize Sustainable Development Laureate, Dr. James E. Hansen. Academician of Academia Sinica and alumnus of our school, Dr. Liu Zhaohan. CEO of the Tang Prize Foundation, Dr. Chen Zhenchuan. The Director of the Foundation's Department of Planning and Development, Mrs. Hu Yingying. Thank you all for coming here today.
Also, in the audience are the representatives of top-ranking high schools in Taipei and Taitung. Even though this is the only high school event Dr. Hansen would attend, we're confident that through us, Dr. Hansen's inspiring ideas would reach many more Taiwanese young people and enable us to become better partners with the world in making our future. Before we begin today's talk, may we have our principal, Dr. Wang Shuli, give us a few remarks.
Good afternoon, distinguished guests and participants, Dr. James Hansen, Dr. Liu Zhaohan, and Dr. Chen Zhenchuan, and Ms. Hu Yingying. We are delighted and honored to have you here. It's our pleasure to work with the Tang Prize Foundation to organize the significant event. To demonstrate traditional Chinese culture and represent the spirit of the Tang Dynasty, Tang Prize Foundation aims to support research that contributes to the world and the human well-being, so as to chart the middle path to achieving sustainable development and in turn make the world a better place. The Tang Prize in Sustainable Development recognizes those who have made extraordinary contributions to the sustainable development of human societies, especially through groundbreaking innovations in the science and technology. We are very honored to invite the Sustainable Development Prize laureate, Dr. James Hansen, who is a pioneer on numerous fronts related to sustainability. We also welcome the teachers and the students from 3 partner schools to join us here in this event, where the young minds of a country will be given the rare opportunity to be enlightened through in-depth conversations with a great leader in science. Last, I would like to thank all of you here for showing your enthusiasm about the topic and the support for our future. Your presence makes a difference for our future together. Thank you very much.
Thank you, Dr. Wang. Now, let's welcome our esteemed guest, CEO of the Tang Prize Foundation, Dr. Chen Zhenchuan, to say a few words.
Dr. Jim Hansen, Principal Wang Shuli, Professor Liu, academicians of Academia Sinica, and especially teachers and young students. Yeah. Welcome everybody to Tang Prize Youth Symposium. Today, we are very honored to welcome Professor Hansen here today to engage in a dialogue with you young students. The Tang Prize is an international prize founded in the year of 2012 by Dr. Samuel Yin. Dr. Yin placed much attention on education at the age of 37. He believed education is a critical institution in our society to prepare our youth in facing the challenge of the future. And ultimately, it is the only way to attain the greatest well-being for the greatest number of the people. The prize is awarded in 4 fields: sustainable development, biopharmaceutical science, sinology, and rule of law. The Tang Prize is global in reach, with laureates selected on the basis of originality of their work, along with their contributions to society in respective of their nationality or ethnicity. All of the young students here today, you are at a turning point in your lives. The choice you make today and tomorrow will decide your future. So the main themes of 2018 Tang Prize Week is sparkling your future. I'm sure that after you listen to the Dr. Hansen's talk today, you will fully realize how important you are, especially in the coming roughly 12 years or so. There could be a mega change if we don't do it from now on. They could, go to a non-linear transitional change. That senior people like us, we feel very ugly. We may just give you a word that cannot return to what it was for people to live. So listen carefully to Dr. Hansen's talk. It's very, very important. Every word he speaks is very, very important. Dr. Hansen is a man of uncommon courage and convictions. In 1988, 30 years ago, then director of NASA Goddard Institute of Space Study, he famously announced in television testimony before the US Congress that global warming is here. As the observed temperature record exhibit an anomalous rise above the statistical noise of natural fluctuations. Dr. Hansen's testimony was an important turning point in the history of global climate change. And 30 years later, all scientists, people, they all think he is correct. On behalf of the Tang Prize Foundation, I would like to sincerely thank Professor Hansen for joining us here today and sharing his life with us. Our thanks go out to the affiliated senior high school of HSNU for arranging these events and welcoming 5 other high school students to participate. And finally, thank you for all for attending here today. I hope this speech will inspire you to be great. I wish you all a wonderful afternoon. Thank you very much. Thank you.
Thank you, Dr. Chen. Now, please welcome the laureates of the 2018 Tang Prize, Dr. James Hansen on stage.
Thanks very much. Thanks very much for coming out. I really like the chance to speak to young people. I'm getting old. I'm 77 years old. I keep working, though, for your sake, but I need to communicate in order for it to be meaningful. So what I'm going to talk about, is this up? No. Okay. So I want to start slideshow. Sorry. Okay, sorry about that. Okay, let's talk about global energy, global energy consumption, and the effect that it has on climate and human health, especially about how young people can turn the problems that energy causes into opportunities. Fossil fuels are remarkable. They powered the Industrial Revolution. Fossil fuels allowed people and products to be moved to greater distances much more easily. Some scholars say that fossil fuels were the real basis for eliminating slavery, although perhaps we have all become slaves in a different way. But fossil fuels raised living standards. People love and use the power that fossil fuels bring. 1 liter of petrol contains the work equivalent of 100 hours by a healthy adult. But now, what do I know that would cause me, a soft-spoken Midwestern scientist, to get arrested protesting in front of the White House? I was lucky to grow up at a time when it was not difficult for the child of a tenant farmer to make his way to a state university. And I was especially lucky because I was able to study under Professor James Van Allen, who built instruments for the first United States satellite. Professor Van Allen told me about observations of Venus. Venus was emitting intense microwave radiation. Did it mean that Venus had an ionosphere, or was Venus extremely hot? The right answer, confirmed by the Soviet Venera spacecraft, was that the surface of Venus was very hot, about 900 degrees Fahrenheit, and it was kept hot by a thick carbon dioxide atmosphere. So Mars, Earth, and Venus confirm the greenhouse effect. The greenhouse effect is the excess temperature relative to what is expected given the amount of sunlight that a planet absorbs. As greenhouse gas amount increases, the excess warming increases. Earth is not too cold or too hot, it's just right for life. Then I was fortunate to join NASA and successfully propose an experiment to fly to the planet Venus. Our instrument was a small 1.5-inch diameter telescope, which took this image of the planet Venus. This cloud is actually a smog of sulfuric acid. as it turned out. So it's not a very romantic planet. And while our instrument was being built, I became involved in calculations of the greenhouse effect here on Earth, because we realized that our atmospheric composition was changing. So I resigned as the principal investigator on the Venus experiment, and because our changes on our own planet are more interesting and important. They will affect all of humanity. I worked on using observations from weather stations to develop a history of the Earth's temperature. And with a team of colleagues, I developed a mathematical model of Earth's climate to run on a computer. After 5 years of work, in 1981, we published an article in Science magazine concluding that Earth had warmed 0.4 degrees Celsius in the prior 100 years. That observed warming matched calculated warming due to the increasing CO2. That Earth would warm more in the 1980s, and that warming would exceed natural variability before the end of the century. We also said that the 21st century would see shifting climate zones, creation of drought-prone regions in North America and Asia, erosion of ice sheets, rising sea levels, and opening of the fabled Northwest Passage. And all of these have since occurred. That paper was reported on the front page of the New York Times, and it led to me testifying before Congress in the 1980s. Testimony in which I emphasized that global warming increases both extremes of the hydrologic cycle. Heat waves and droughts, on one hand, directly from the warming, but also because a warmer atmosphere holds more water vapor with its latent energy, rainfall can occur in more extreme events. There are stronger storms and greater flooding. The Bush administration did not like my testimony, and the Office of Management and Budget inserted some changes in my testimony that made the effects of climate change seem more innocuous. After I complained publicly about these alterations, global warming hoopla became time-consuming and distracted me from doing science. So I decided to go back to strictly doing science and leave communication to scientists who were good at media communication and even enjoyed it. However, by 15 years later, evidence of global warming was much stronger. Most of the things we mentioned in our 1981 paper were established facts. And I was privileged to speak twice to the President's Energy Task Force, Vice President Cheney, and 6 cabinet members. But U.S. energy policy continued to focus on fossil fuels. At the same time, my view of the safe level of atmospheric CO2 began to diverge sharply from that of the prominent climate science communicators. And by then, we had 2 grandchildren. So I decided that I did not want them in the future to say, Opa understood what was happening, but he didn't make it clear. So I decided to make a public statement criticizing the lack of an appropriate energy policy. When I encountered resistance to giving a talk in Washington, Professor Van Allen kindly arranged for a lecture at the University of Iowa in October of 2004. And 14 months later, I gave a similar talk at the 2005 American Geophysical Union meeting. That talk led to several calls from the White House to NASA headquarters. And I was told that I could give no more talks or speak with the media without explicit prior approval by NASA headquarters. So I let that go on for a few weeks. And then I informed the New York Times about these restrictions. And NASA was forced to end the censorship. But there were consequences. I had used the first line of the NASA mission statement to understand and protect the home planet, to justify my talks. Soon, this line of the mission statement was deleted, and it has never appeared again. So in the next few years, I was drawn more and more into communicating the urgency to change energy policies while still researching the physics of climate change. So let me describe two of the most important pieces of that physics. Adding CO2 to the air is like throwing another blanket on the bed. It reduces Earth's heat radiation to space. So there's more energy imbalance, more energy coming in from the sun than heat energy going out to space. As long as more energy is coming in than going out, then more global warming is in the pipeline, and it will occur without any additional greenhouse gases. We can now measure Earth's energy imbalance by measuring the heat content in Earth's heat reservoirs. The biggest reservoir, the ocean, was the least well measured until more than 3,000 Argo floats were distributed around the world's oceans. These floats reveal that the upper ocean is gaining heat at a substantial rate, and the deep ocean at a smaller rate. Energy is also going into net melting of ice all around the planet. And the continents, to depths of tens of meters, are getting warmer. The total energy imbalance is now about 3/4 of a watt per meter square. That's about 20 times greater than the rate of energy use by all of humanity. It's equivalent to exploding about 500,000 Hiroshima atomic bombs per day, 365 days per year. That's how much extra energy Earth is gaining each day. This imbalance means there's more warming in the pipeline without additional CO2. It also means if we want to stabilize today's climate, we must reduce CO2 from 410 ppm, parts per million, to at most 350 ppm. That's the change needed to restore energy balance. Now, climate change deniers argue that the sun is the main cause of climate change, but the measured energy imbalance occurred during the deepest solar minimum in the record, when solar energy reaching Earth was least. Yet more energy was coming in than going out. So the effect of the sun's variability is overwhelmed by the increasing greenhouse effect due to fossil fuel burning. Earth's history contains remarkable information on climate change. Global temperature, atmospheric CO2, and sea level over 800,000 years can be derived from ocean cores and Antarctic ice cores, from ocean sediments and from snowflakes that pile up year after year, forming the 3-kilometer thick ice sheet on Antarctica. Sea level is a measure of ice sheet size. When the ice sheets melt, sea level rises. Climate change on such long time scales is instigated by oscillations of Earth's orbit and the tilt of the Earth's spin axis. which alter the seasonal and geographical distribution of sunlight on Earth. These orbital forcings are weak and slow, changing on timescales from 20,000 to 100,000 years. Climate change on these long timescales are very large. The large magnitude is due almost entirely to two powerful amplifying feedbacks: ice sheets and CO2. As Earth warms, ice melts and exposes darker ground that absorbs more sunlight. And as the ocean warms, it releases CO2 like a warm Pepsi. CO2 changes more slowly than ice sheets, so it is the control knob on global temperature, as you can see from this remarkable comparison of atmospheric CO2 and Antarctic temperature. The same amplifying feedbacks must occur today. Physics does not change. As Earth warms, ice sheets will melt. CO2 and its companions, methane and nitrous oxide, will be released by the warming ocean, melting tundra, and wetlands. We can't say exactly how fast these amplifying feedbacks will occur, but they will occur. Let's tack modern data onto the paleo record. CO2 is shooting off scale. Temperature is also rising, but it has not caught up to the CO2. That takes time. Why? First, the ocean has great thermal inertia. It takes 100 years for the ocean surface temperature to reach 2/3 of its equilibrium response. Second, there are the slow feedbacks. Ice sheets do not melt overnight. The paleoclimate record shows that sea level lags temperature by a few centuries. So does that mean that coastal cities are safe for several centuries? No, because human-caused change in greenhouse gases is much faster than any prior change in Earth's history. In our paper, Ice Melt, Sea Level Rise, and Superstorms, we estimate that multi-meter sea level rise will occur in 50 to 150 years if CO2 continues to increase rapidly. Sea level rise does not need to reach several meters before the economic impact becomes intolerable and the world likely becomes ungovernable. Cities become dysfunctional long before they are totally underwater. These are all of the world's largest cities. As you can see, more than half are on coastlines. Florida, the Netherlands, Bangladesh would be underwater, also a good part of China. The second irreversible impact of rapid, large climate change would be on other species. We cause stress on other species in many ways as we take over the planet. We could commit to extinction 1/4 to 1/2 of all species from the combined effect of these stresses and rapidly shifting climate zones, according to estimates of the Intergovernmental Panel of Climate Change. Coral reefs are the rainforest of the ocean, harboring more than 1 million species. They are threatened by many stresses, including ocean warming, which causes coral bleaching, and ocean acidification, which in the extreme can dissolve the carbonate exoskeletons. We are losing more than 1% of the coral each year. If rapid emissions continue, especially with rapid sea level rise, most coral could be lost. However, if we reduce CO2 emissions to stabilize shorelines, we will also solve this problem with coral reefs. Older people notice that climate is changing, especially in summer. Year-to-year variability of seasonal temperature in the 20th century formed a nice bell curve about the average. But now the bell curve has shifted. What was an unusually extreme hot season last century is now occurring much more often. The change depends on location. In middle latitudes in the United States and Europe, the shift is a bit more than 1 standard deviation in the summer, but smaller in winter. In the subtropics, such as the Mediterranean and Middle East and Southwest U.S., every summer is now hotter than average climate, the average climate 50 years ago. And that's almost true in Southeast Asia. Increased heat causes dry regions to have more drought and wildfires and a longer fire season. But warm air holds more water vapor, so wet regions and rainy seasons can have more extreme rain and floods. Low latitudes are becoming less livable outdoors in the warm season, and more than half of the jobs are outdoors in agriculture or construction. Higher temperatures also lead to a measurable increase of violence. These things are happening. Dry regions are having more extreme events. Here are fires in Greece this year, and these are more images of the impacts of the fires in Greece. Fires have always occurred, but despite massive efforts to extinguish fires in the United States, the area burned is increasing. 100-year floods are now occurring more often than once a century. There were unprecedented rainfall amounts this year in Japan. A warmer ocean surface and more water vapor in a warmer atmosphere provide more fuel for stronger tropical storms, tornadoes and thunderstorms. This super typhoon had the strongest sustained winds over land ever recorded, reaching 195 miles per hour, which is well over 300 kilometers per hour. Yet the urgency of the climate crisis is not recognized by most of the public. Because of the ocean's thermal inertia, much of the warming is still in the pipeline. That warming will drive slow feedbacks, such as melting of permafrost and ice sheets. So if the world does not reduce fossil fuel emissions, it will be an injustice to young people, because we will hand you a situation out of your control. It would also be an injustice of the industrial north, which is burning the allowable carbon budget for the entire world. And of course, an injustice of humans to all other species. Now you know why I got arrested. After I was arrested 5 times, I finally realized, hey, this is not working. Drawing attention to the injustice of climate change does not alter government policies. Energy use continues to grow. People want to raise living standards. People want to travel, and they will. They need air conditioning. The world needs energy. Governments give large subsidies to renewable energies and pretend this will cause fossil fuel use to decline. Courage to use the true scientific method is lacking. So governments continue to seek fossil fuels, and there are plenty to find. We have burned so far only the purple parts of these fossil fuels. The science is crystal clear. We must leave most of the remaining carbon in the ground. And we must extract some CO2 from the air, which is possible via improved agricultural and forestry practices. However, we must leave young people a feasible task and tools to address it. So, young people, you must take up the fight, and you must demand your rights. But to succeed, you must understand the matter and use the scientific method. We old scientists failed to change the world's course. I hope to explain to young people what I learned in Sophie's Planet. Thanks to the Tang Prize, I should finish that book over this winter. The core of the scientific method is simple in principle. You must use all the data, be very skeptical of your interpretation, and honestly reassess from scratch when new data become available. Your preference, your ideology, must not affect your assessment. So in fact, it is difficult. Let's now consider human health as another huge issue associated with energy. China did an inadvertent experiment by providing free coal for winter heating to people in North China for several decades. It reduced the life expectancy by 5.5 years. Globally, outdoor air pollution, mainly from fossil fuel burning, is killing more than 3.5 million people per year. That's 10,000 people per day. The aerosols that people breathe are so tiny that they enter the bloodstream, causing cardiac problems as well as respiratory problems. Indoor air pollution from burning of coal, wood, and other biofuels kills an additional 3.7 million people per year. Because these fuels are used for cooking, women and children are especially affected. Many of the deaths from air pollution are prolonged and painful to the victim and the family. The crucial requirement to solve both health and climate problems is abundant, clean, carbon-free energy. However, fossil fuels will not be replaced by an alternative unless the entire energy system is economic relative to coal and gas, including costs of additional transmission lines and energy storage if those are necessary. India will soon pass China in population, and India will pass the United States in carbon emissions, becoming second to China. Renewable energy, which is the green area in these graphs, provides only a tiny portion of the energy. It cannot stop the growth of fossil fuels, let alone cause their phase out. Energy history of the United States is educational. Wood was the first energy source, but coal, with greater energy density, powered the Industrial Revolution until the more convenient liquid and gas fossil fuels were discovered. Because fossil fuels are a finite resource and a big pollution problem, it was hoped that peaceful use of nuclear power would be a major long-term energy source. There's enough nuclear fuel in the ocean to last forever, for billions of years, so it would be possible to stop mining of uranium. Nuclear power could help eliminate CO2 emissions as well as air and water pollution. However, development of nuclear power practically stopped in the 1970s. What happened? The root problem for nuclear power is concern about health effects of atomic radiation. Until 1956, it was assumed that there was a threshold for harm, consistent with the idea that radiation is probably not dangerous if it is less than the amount that we get from cosmic rays and from radioactive elements in the soil. Some scientists even argue for radiation hormesis, the idea that low levels of radiation are beneficial to health. However, in 1956, the National Academy of Sciences Baer Committee, that's Biological Effects of Atomic Radiation, declared that the tiniest amount of radiation is harmful. Linus Pauling used the idea that even the tiniest radiation is harmful to help achieve a ban on atmospheric testing of nuclear weapons by the US and USSR. But this incidentally had an effect on public perception of nuclear power. Public attitudes were also affected by the 1979 disaster thriller film, The China Syndrome, about the danger of a nuclear meltdown. The film almost coincided with an actual accident and partial core meltdown at the 3 Mile Island power plant in Pennsylvania, the United States. So enthusiasm for nuclear power in the US dissipated, even though it was determined later that the radiation released did not harm Pennsylvania residents. This is from a concert held that year in, oops, there's no sound. Here we go. So did you hear the, the line in the song, "Give me the warm glow of a wood fire"? And remember that 10,000 people per day die from indoor air pollution. Proponents of nuclear power continue to argue that the Baer Committee was wrong, that LNT is not correct and was ideologically driven. I doubt that this battle will be fruitful. Small radiation effects are difficult to prove and depend on the circumstances. In such case, health professionals are likely to prefer the strictest criterion, which is LNT. However, young people have a good basis to be very unhappy with us old people for not being scientific, for not being objective. I believe that young people should demand an honest comparison of the health and environmental effects of nuclear power, the health and environmental effects of fossil fuels, and the health and environmental effects of renewable energies. We have science academies capable of such evaluations, which should be presented side by side. Young people have more reason to question the wisdom of us old people. President Clinton, 25 years ago, terminated R&D on nuclear power just when the Department of Energy was ready to build an advanced generation nuclear reactor with major improvements over today's reactors, which are 50-year-old technology. Nuclear power in the United States has an outstanding safety record, but next generation nuclear power can be even much safer and produce less nuclear waste. We would not force solar energy or windmills to use 50-year-old technology. Now, I am not advocating any specific technology. There are numerous startup companies proposing small modular nuclear reactors that are inherently much safer than old technology. But unfortunately, old geezers control the money and run the so-called environmental organizations with a religious-like anti-nuclear fervor. Renewable portfolio standards forced on utilities are designed to kill nuclear power by denying nuclear power clean energy credit. However, the Nuclear Regulatory Commission and the Department of Energy need to facilitate progress with modern technology, which they are not so far doing well. So let me give the last word on this topic to my oldest grandson. Here, at about age 7, reading an Indiana Jones book about an urgent problem. A few years later, when he was 10 years old, Connor correctly identified the two basic conclusions about the energy climate matter. First, if grown-ups keep doing what they're doing, and kids can't figure out a time machine that actually works, then kids are screwed. And second, some grown-ups are scared of nuclear power, but what about fossil fuels? We know that using fossil fuels is not safe. It's very dangerous. Now let's consider the solution to the health and climate problems. The essential requirement is a rising carbon fee to make the price of fossil fuels honest by including their human health and climate change costs. It's easy to implement an across-the-board carbon fee, collecting it at the first sale at domestic mines and ports of entry. If 100% of this collected fee is distributed equally to all legal residents, we obtain a simple, transparent, market-based approach that spurs innovation. With the present distribution of energy use, 70% of the public will make money. But if they want to stay on the positive side of the ledger, they need to pay attention to the price of things on the shelf. Products that employ a lot of fossil fuel in their production will become more expensive. Most rich people have a large carbon footprint from large houses and flying around the world, so they will lose money, but they can afford it. Fee and dividend spurs the economy, creating jobs, increasing GNP, and increasing government revenue. Fee and dividend is the one effective international approach. When the U.S. and/or China adopt a carbon fee, they will also impose border duties on products from countries that do not have an equivalent carbon fee. That will be an incentive for other countries to adopt a carbon fee so they can collect the money themselves. So the crucial underlying requirement is a rising price on carbon to make the fossil fuel price honest. Some regulations will still be required, and governments must support R&D because it is essential to have 100% carbon-free electricity. It's important to recognize national responsibilities for climate change, which is proportional to cumulative emissions. The United States, United Kingdom, and Germany are much more responsible for climate change than the developing countries. In other words, the West burned much more than its fair share of the global carbon budget. That is the budget that's permitted if we are to stabilize climate and avert disasters. This is an added reason for the West to assist in reducing emissions in developing countries, in addition to the fact that we're all in the same boat together. So how can we reduce emissions from the big future emitters? If I want to be popular, if I want to find research support easily, I must say that renewable energies can provide all of our energy. If I want to be a good scientist, I must look at all the data. Does it make sense to place all of our eggs in one basket, to make the assumption that renewable energies by themselves will rapidly replace fossil fuels? I think young people should be angry. Old people do not have the right to gamble the future of young people on that assumption. I doubt that the climate problem will be solved by 190 nations sitting around a table. What is required, I believe, is the United States and China to agree on the need for a carbon fee. They could readily impose it on a near global basis. However, this will not happen in the absence of technological advances that allow practical economical movement to carbon-free electricity, especially in countries such as China and India. For that to happen rapidly requires concerted, high-priority technology cooperation. And by the way, the notion that humanity can escape to Mars is nonsense. Either we learn to work together, preserving our remarkable home planet, or we sink to the abyss together. China and India are not the only big emitters. There is also the United States, which has withdrawn from the Paris Agreement and says that climate change is a hoax. Nevertheless, there is a basis for optimism. The United States is still a nation of laws. 21 young people, including my oldest grandchild, and I have filed a lawsuit against the federal government demanding a national plan to phase down emissions rapidly. I expect that we will win this case, even with a conservative Supreme Court, because our case is based on the most fundamental constitutional principles. Young people are being deprived of life, liberty, and property without due process of law. They are not receiving equal protection of the law. It's analogous to the case of civil rights in the 20th century. But the courts cannot write laws, so it is important to also influence the legislative branch. Good progress is being made in the U.S. by a rapidly growing organization, Citizens Climate Lobby, which has carbon fee and dividend as its sole objective. CCL uses the democratic process. It visits Washington, speaking to Congresspeople and their staffers about fee and dividend, and also writes op-eds and letters to the editor. Joining this organization is probably the single most important thing a citizen can do to address climate change. There are CCL branches in India, but not in China or Taiwan. So that's something to consider. Thank you.
Thank you, Dr. Hansen, for your educational and inspirational speech. Now it's time for Q&A, so please take a seat. Now, as today's hosts, may we have the privilege to ask the first few questions? Okay. I did a bit of homework, and your job title right now, Director of Program on Climate Science Awareness and Solutions at Earth Institute in Columbia University. What exactly does this job require you to do?
Okay, how about this? Okay. Well, yeah, I retired from the government because, you know, I was working 40 hours a week for the government, for NASA, and 40 hours a week against the government and trying to get policy changes. And the government didn't like this, so it became more and more difficult. So I retired and formed an organization at Columbia University. And I call it Climate Science awareness and solutions, because what I learned in the prior decades was that just doing climate science doesn't make anything happen. You have to first of all make the public aware. So that's the awareness. We need to learn how to communicate, which was very difficult for me. I was a scientist who, you know, didn't communicate well, and I didn't like trying to communicate. So after I testified in 1988 and 1989, and the media got interested in this, then I bailed out and decided to just do science and let other scientists who enjoy communications do that. However, I ended up not satisfied with the message, and so I decided I have to try to communicate, even though I'm not a good communicator. So that's science awareness and solutions. The other thing is I also realized the solutions, you have to be objective about defining what is needed. You know, otherwise, if you let the politicians define it, even if you make people aware, if you let the politicians define the solution, it turns out they don't work, because in the United States and in more than a dozen countries that I went to, I found that the role of money, the special interests, have a huge impact on what governments will propose. So they don't propose something simple and honest like a carbon fee and dividend. And so I felt the organization has to cover the waterfront, from science, awareness, to solutions. And so I have 5 people. Actually, as I mentioned, it's very difficult to get support. I have to get the money for supporting 5 people from donations from philanthropists. And if you say, I think we probably need nuclear power, that makes you very unpopular in the United States with more than half of the people who have funding. But if I'm going to be an honest, objective scientist, I have to say what the science tells me. That's actually why this prize that I'm getting from the Tang Foundation, it turned out to be very useful, because I was thinking, I have to go back to fundraising, I can't finish my book. Well, now it allows me some support so I can finish my book this winter, and then next spring I'll go out and try to raise money again. But anyway, that's a long story. But it's necessary to cover this whole waterfront: science, awareness, and solutions.
Okay, thank you, Dr. Hansen. And now I have another question for you.
Mm-hmm.
In your opinion, which sustainable energy, nuclear, is the most likely to be the first to replace traditional energy or fossil fuel?
I didn't quite understand the question.
Like, other than nuclear energy, like, because it's not that possible for all countries to immediately have nuclear energy.
Right.
So other than that,
Yeah.
which one is more feasible?
Yeah. Okay. Of course, I think that renewable energies are part of the solution. I now live on a farm. I've got a very big 3-story barn, and I've got it covered on the one side by solar panels. We generate twice as much electricity as we use, and the utility is forced to buy it from us. That's the rule. And that works fine as long as it's a small fraction of the total energy. If everybody was doing that, then at present we wouldn't be able to use that energy because it only comes when the sun is shining. And that makes a big problem for utilities. But as long as it's a small piece, that's part of the solution. And maybe batteries will allow you to store energy and make these renewables a bigger part of the solution. You have to be a little cautious about that. I mean, Elon Musk is now building a battery big enough to put in your basement, you know, and rich people can do that. but that battery only takes care of the diurnal cycle. You've got, sometimes you go 3 weeks with the wind not being strong, and so the windmills aren't working, and the seasonal cycle is much longer. So that's, we're a long way from having energy storage that would allow renewables. And at present, it's very expensive. Even if the solar panels are free, you give them, if you could somehow build them for nothing, it still is an expensive system because you've got to get the energy from the solar panels, to places where the sun isn't shining, and you have to have energy storage. It makes the, anyway. So I'm not answering your question. And the reason I'm not coming up with anything other than renewables plus nuclear is that nobody has done that yet, you know. It may be that there's something out there, but it hasn't been found. And the way we will find it is with this carbon fee, because the entrepreneurs will have the incentive to be looking under every bush for every possible energy source if there's that economic incentive that the carbon fee would provide. And of course, one thing the carbon fee will do is encourage energy efficiency and conservation, making the energy more, if it's coming from fossil fuels, make it more expensive. So I don't have a very good answer. If I had, of course, if I knew that, then I'd run off and make billions of dollars.
Okay, thank you, Dr. Hansen. And now let's open the floor for everyone if you have any questions. We have some representatives of partner schools, right? And if you have any questions.
Hello, Dr. Hansen. I know that climate change is a bad thing, but global warming, some people say, are good things because when global warming is not too balanced, it will cause like wildfire in your presentation. And I was always wondering, how can we find a way to balance the temperature of global warming, because it's bad if it's too high and it's bad if it's too low. Thank you.
Yeah, climate naturally fluctuates by very large amounts, as I showed on this graph for 800,000 years. 20,000 years ago, the world was 5 degrees Celsius colder, and there was an ice sheet that covered Canada, and sea level was 130 meters lower. But those changes occur on very long time scales, and you know, we would, if it weren't for humans, we would go into another ice age sometime fairly soon, if you consider 10,000 or 20,000 years to be soon. But now humans can avoid an ice age with the chlorofluorocarbons that you can produce in a single factory. Those natural forcings that cause those large climate changes are actually very small. It's just that they're present for thousands of years, and they slowly have an effect through these feedback mechanisms. But humans are now in control. The human-made changes of atmospheric composition overwhelm the natural forcings. So now, as to whether there are local or regional benefits from warming, perhaps in some places. However, the problem is that the biggest issue is sea level. We know that the last time it was a bit warmer than today was the Eemian, 120,000 years ago, and sea level rose 6 to 9 meters higher than today. Sea level on these long timescales is highly variable by more than 100 meters. But humanity established its cities based on a stable sea level. Now we've got enormous infrastructure on coastlines. We can't afford to have the coastlines changing substantially. The economic implications would be incalculable. The other thing we're already beginning to push the system in an unpleasant way is the low latitudes are becoming unpleasant in the summer. You can already notice with just the warming of a little more than 1 degree Celsius on a global average, you can see, and you should notice in Taiwan, if you're as old as I am, you would notice, that I actually haven't looked at weather records in Taiwan, but at this latitude, it is becoming more unpleasant in the summer. And it's going to cause a pressure for migration from the tropics. And it's even affected the subtropics, the Mediterranean region and the Middle East are becoming unpleasant in the summer. So if we stay on this path, 2 or 3 degrees Celsius warming, which would be 2 or 3 times more than the warming that's already occurred, it's going to have an effect on the population at low latitudes, which will make the planet difficult to govern, I'm afraid. You know, we established our nations, you know, with a climate that has been stable for 10,000 years, and now we're suddenly taking off. And I think, so it's clear, I think it's scientifically reasonably clear that you can't, that you'd like to stay close to the climate of the last 10,000 years.
Okay, does anyone else have any questions, especially the partner schools?
Good afternoon, Professor Hansen. I'm Jian Jingrong from Taipei First Girls High School. And I would like to ask you that in Taiwan, we're now facing a problem between nuclear power and fossil fuels too. There's a newly constructed nuclear power plant that can produce energy effectively and safely, but the government stopped its functions since there are some people against it and the government wants their votes. What will you suggest us to do to help the situation? Thank you.
Yeah, I think that the first thing to do is to try to use the scientific method to help the public be as objective as possible. So I mentioned some things where you need to compare. There's danger associated with every energy source. There are issues with every energy source, and you need to compare them in an objective way. The old technologies, and the Taiwan nuclear plant is a relatively, it's the light water reactor of the type which it can be operated safely. In the United States, we've had more than 100 of them operating for several decades. And it has, nuclear power has the best safety record of all energy sources. But we need to move to even better technologies. And Taiwan is actually a very interesting place. And I could have a big impact on the future of the whole planet because, first of all, Taiwan has a population that is relatively well educated compared to most of the world. And I think has the potential of being objective in assessing the situation. But it's a place which you would think, oh, this is the last place that would be an example for nuclear power because you're just sitting on a volcano. I mean, you're sitting on a fault line. And, but, in fact, we know how to make nuclear power plants that are safe even if you have earthquakes. And the simplest way to do it, by the way, is to have a nuclear power plant on a ship. Well, I helped organize a workshop in China 2 years ago. And the principal conclusion that we came out with was, boy, it would be really wise to make nuclear power plants on a ship. It's very easy to connect the ship electrically to the places that need the energy. And the ship can ride out an earthquake or tsunami or a tropical storm without any problem. Studies of this at MIT and other places have shown that this is not a problem. So you don't have to worry about these natural disasters affecting the nuclear power plant. It's just too bad. And I actually learned in talking to some experts that there were some times when there was a desire to do such things, and the United States government prevented it. This is one thing I'm going to really focus on in trying to educate, trying to inform the situation in the United States, because we burned much more than our fair share of the carbon budget. So we have an obligation to actually help, not prevent other countries from developing technologies that could solve the problem. So this, I'm wandering from the question. What was, did I answer the question? It's an important, these are important issues which need to be brought forward. And they can be brought forward most effectively by young people. I mean, I hate to put the burden on high school students, but in the United States, we had examples recently of the power of young people. In 2008, everyone had agreed that Hillary Clinton was going to be the candidate for president from the Democratic Party. But young people didn't prefer her. They preferred Barack Obama. So they started knocking on doors in Iowa, which is the state I come from, in all 99 counties. And instead of her winning the nomination, Barack Obama got the Iowa votes, and then he got the nomination, and he got the presidency. He owed that to young people, frankly. And they assumed that he would do what was necessary to deal with climate, because that was one of his campaign issues, that he said we have a planet in peril. But he did not propose such policies as a carbon fee, as a rising carbon fee. He had an economic emergency in 2008 when he was right after he was elected. But he wasted that crisis. He could have used that as part of the rationale for getting a carbon tax or carbon fee, but he didn't do that. So my message to young people is you need to not only stand up for your rights, but you need to also understand what is needed and make sure that politicians are actually doing what is necessary. We had the other example was just 2 years ago during the 2016 election. Bernie Sanders is a socialist who nobody would have given a prayer of getting a nomination in the United States. But he almost got the nomination because college students on every campus in the U.S. were out in favor of Bernie Sanders. So young people have tremendous power, and it just needs to be harnessed.
Welcome, Dr. Hansen, to our school. Well, I have one question, which is, I would like to go on the question that the student just raised. What I mean is that, what do you think that we people of a certain country can do when we are facing the, for example, the energy policy of our government is not based on, for example, what you just offered, for example, like scientific research or scientific statistics, but abducted by ideologies? Thank you so much. What do you think that we people can do? Thank you so much.
Yeah, well, you live in a democratic country. You know, one thing the last thing I mentioned in my talk was the possibility of an organization like, or a branch of Citizens Climate Lobby. It's a organization that advocates a carbon fee to make the price of fossil fuels honest, but gives the money to the public. It's very difficult for politicians to do that. Politicians like to give money to the special interests that provide, that they get money from. So yeah, democracies are always difficult to maintain. It can only be maintained if the public puts some effort into it. And I think, and one difficulty that we have is that in the United States, the Citizens Climate Lobby is now more than 90,000 people. They're mostly old people. We need to get more. Of course, retired people have time to go visit their congresspeople and write letters to the editor. But we also need young people to put pressure on the democratic political system. Because I think that we can still get democracies to work. I mean, in the bottom line of my book, Sophie's Planet, is going to be, I think we need a third party in the United States, because what I've found is that both political parties are in bed with the special interests. And it's very hard, and they've become so polarized that we're swinging between extremes like Trump on the right, and these two extremes won't even listen to each other. Most people, though, are more in the middle. And I think in a case of my country, I think we need a third party which would make the United States work the way that it did decades ago. You know, I was born before the United States entered World War II. So I grew up in the era of Harry Truman, Dwight Eisenhower, and JFK, Jack Kennedy, as presidents. At that time, Truman was, in my opinion, a great president. He was the force behind the Marshall Plan that helped Europe and Japan recover from the war. He encouraged the United Nations, the growth of the United Nations, and the United States encouraged the Universal Declaration of Human Rights. So it was recognized then that there's an interdependency among all the nations, and you can actually raise all boats at the same time. The United States got wealthy after World War II, but so did many other countries. It was a general cooperation, and now we have this divisive, each man for himself, America first. We have a president that actually goes around the world saying that. We have to get a party which I say would make America America again. But that's, and cooperate and recognize our responsibility for the global situation. So the present position of our president is, oh, it's all a hoax, that climate change is a hoax. Well, I hope that by the next election that things are going to change. And all of the scenarios that we're running in our organization, Climate Science Awareness and Solution, we start the scenarios in 2021. We assume we're going to have a chance to get on a different world path in 2021, because if we stay on the present one, young people are unfortunately in trouble.
Hello, Dr. Hansen. I've been paying attention about this issue recently, but I saw that a lot of goal of like carbon emission, carbon dioxide emission, or some goal of that isn't achieved by a lot of countries, and a lot of countries even collectively ignore that. How would you consider that? How would you consider this, and how would you solve it? Thank you.
Yeah, you know, that's the problem with the approach of the United Nations. You know, after this climate change became a public issue in the late 1980s, it took only a few years to get the Framework Convention on Climate Change adopted at Rio in 1992. It was agreed by 190 nations that we should avoid dangerous human-made interference with climate. However, so that was actually impressive that they went so quickly to an agreement that we should avoid the bad consequences. However, the efforts to do that were the Kyoto Protocol and then recently the Paris Agreement, in which you're asking each nation, oh, would you please try to do better? You know, that's not going to work. What is needed is the United States and China. If we would both, and China does not deny the reality of climate change, And they also are going to realize very soon that China is vulnerable. They've got hundreds of millions of people living near sea level, and they're vulnerable to the regional climate change also. So I see the possibility that those two countries could agree, oh, we better have a carbon fee. And if they do that, they can impose it near globally by saying we're going to have a border duty on products from countries that do not have a carbon fee. That encourages these other countries to have their own carbon fee so they can collect the money themselves rather than have China and the United States collect it at the borders. So economists agree this would actually work. And it's really the only thing that will work. As long as fossil fuels don't have to pay their costs, people will just keep burning them. But you can impose this near globally with an agreement between the United States and China. So I see that, and that's the kind of thing where we really have to educate the leaders. We can't let somebody, when you elect somebody like Obama who wants to solve the problem, then he's got to take the kind of actions that are needed. He's got to negotiate with China, and I think China would be ready to negotiate. They don't want big climate change.
Now, that's all the time we have for Q&A today. And thank you, Dr. Hansen, and everyone for spending the whole afternoon with us. Dr. Hansen, please take your seat. Now, for the closing remarks, we would like to have our principal, Dr. Wang Shuli, give us a few words.
Let me say again. Dr. James Hansen, Dr. Liu Zhaohan, and Ms. Hu, distinguished guests and participants, it is with my deepest gratitude that I want to make today's closing remarks. First, I would like to show our deepest appreciation to Dr. Hansen for being here and sharing his soul-provoking insights and rich life experiences. We hope you have enjoyed this exchange of ideas with our students as much as your stay in Taiwan. Next, we want to thank the Tang Prize Foundation for helping us organize this event. Last but not least, we want to thank everyone here for your participation. All of us here, I believe, have learned a lot from today's talk. We hope those promising young people will lead us to chart the middle path to achieving sustainable development and make the world a better place. Thank you. Thank you.